Hi, my name is Alyssa, and I'm a math and science tutor. Today, I'm talking about arc length and inscribed angles. Specifically, I'm going over common problems that you'll find on your homework or if you're taking a test in a trigonometry course. Our first problem asks us to find the length of the arc, which is opposite to an inscribed angle of measure 30 degrees in a circle whose radius length is 15 centimeters. All right, let's break this down. The first thing that you're going to need to know about is the Central Angle Theorem. The value of a central angle is twice the value of the inscribed angle that intercepts the same arc. Now that sounds like a lot, so let's go over what that means with this diagram. First things first, our inscribed angle is our angle in blue, and our central angle is our angle in red. And the arc length is all the way from point A to point B, highlighted in green. What the central angle theorem tells us is that when we have an inscribed angle, our blue angle, that makes this arc length in green, and we have a central angle that also makes the same arc length in green, we know that the central angle will be equal to 2 times the inscribed angle. And we can use that information to solve our problem. Okay, so find the length of the arc which is opposite to an inscribed angle of measure 30 degrees in a circle whose radius length is 15 centimeters. The inscribed angle is half of our central angle. So we're going to multiply this by 2 to get our central angle. And our central angle will be 60 degrees. Now we can use this information to solve for the arc length, because we have 2 equations that allow us to solve for the arc length when we have a central angle and a radius. The arc length is equal to the central angle times the radius. This equation only works when you're dealing with radians, so we need one that's going to work with degrees because that's what we're given. That equation is going to be the arc length is equal to our theta in degrees over 360 degrees times 2 pi times the radius. So let's plug in our values to this degrees equation and solve. We have a central angle of 60 degrees over 360 degrees times 2 pi times our radius of 15. Right away, we can simplify this. We can multiply 2 times 15 to get 30 pi times 60 over 360. And now let's simplify this. I'm going to write this over here for more room. We know that 60 goes into 360 6 times, so we can rewrite this as just 1/6. And now we still have our 30 pi. 6 goes into 30 5 times. So our answer is going to be 5 pi, and we have units of centimeters, so 5 pi centimeters. Let's try another problem. Find the length of the arc, which is opposite to an inscribed angle measure of 45 degrees in a circle whose radius length is 5 centimeters. Again, we're working with degrees, so we're going to rewrite our equation. Theta over 360 degrees times 2 pi times our radius is equal to the arc length, which is exactly what we need. We have 45 degrees for our inscribed angle, but we need the central angle. So we need to multiply 45 times 2. 45 times 2 is equal to 90 degrees. Now we can plug everything into our equation and solve. We have 90 over 360 degrees times 2 pi times our radius of 5. Right away, we can write this as 10 pi, and 90 over 360 needs to be simplified further. It turns out that 90 can go into 360 4 times, so this changes to 1/4, and we still have 10 times pi. And we can simplify this further. 1/4 times 10 is 2.5 pi, and our units, I believe, were centimeters. Yes. So 2.5 times pi centimeters is our final answer for the arc length. I hope this helped you. If you'd like to see more videos where I go over common trigonometry homework and test problems, please make sure to like this video and subscribe to my channel. Thanks so much for watching.